Welcome. In this video we will learn about estimating the number of clusters. In previous video what we did is we had given the number of cluster, that is 5 number of clusters in advance in the program itself only. We had defined that 5 cluster itself only. But here we will make the program to figure out how many clusters are present. So this is contrast to parametric techniques where we assume that the underlying data follows a standard probability distribution. Mean the shift finds a lot of application in fields like object tracking and real-time data analysis. We consider the whole feature space as a probability density function. We start with the training data set and assume that they have been sampled from a probability density function. So let's open my directory which contains my file. So here is data clustering.txt with a lot of points with their respective coordinates. So now here is meanshift.py, a code which will estimate the number of cluster with mean shift algorithm. In the last video we saw k-means algorithm. In this one, to figure out the number of clusters, that is how many group of cluster are present, we are going to use mean shift algorithm. First let's see the output. Let's open the terminal and run the command as python space meanshift.py. You can see that representing the cluster and their centers. The center of cluster, these are the 5 coordinates of 5 different center of cluster, and here it has successfully figured out that the number of clusters in input data is 5. Here you can see this in figure, the clusters 5 different centers. You can see 5 different clusters. So now let's see what is this mean shift program, or how we have utilized the mean shift algorithm. So the first is import numpy as np, which we know, and import matplotlib, which we also know. Now this new one is from sklearn.cluster. In that, import mean shift, that is the algorithm we are going to use, and estimate bandwidth. After that, from iter-tools, import cycle. This module implements a number of iterator building blocks inspired by construct from APL, Haskell, and SML. Now let's load the data from input file. Here I am using data clustering.txt. So x equals to np load txt data clustering.txt. Now estimate the bandwidth of input data. So bandwidth is a parameter of underlying kernel density estimation process used in mean shift algorithm. The bandwidth affects the overall convergence rate of algorithm and the number of cluster that we will end up with in the end. Hence this is a crucial parameter. If bandwidth is small, it might result in too many cluster, whereas if value is large, then it will merge distinct clusters. So bandwidth underscore x, estimate bandwidth x, quantile equals to 0.1, and sample length x. Now let's train the mean shift clustering model using estimated bandwidth. The mean shift model equals to mean shift bandwidth equals to bandwidth bin seeding goes to true, mean shift model dot fit. So this is the training of mean shift clustering model using estimated bandwidth. Now extract the center of all the clusters. So cluster center mean shift model dot cluster centers print center of cluster cluster center. So this will give the output which we saw, all 5 coordinates, that is cluster centers. We have already got the center of all the cluster. So now we have to estimate the number of cluster. For that, labels equals to mean shift model.labels, new cluster is equal to length, and print the number of cluster in input data equals to num underscore clusters. So this will give the output, that is the number of clusters. Let's plot the points and cluster center to the output window. For that, plot.figure markers equals to 0 star xvs, for loop, and so on. This complete code will plot the points and cluster center to the output window. Now put my window name as cluster and show it to the output. So plot.title cluster plot.show. That's it. So in this way, we have written the code for estimating the number of cluster with mean shift algorithm. Now let's move to the output again. Open the terminal and run the command as python space meanshift.py. You can see that representing the cluster and their center, there are total 5 numbers of cluster are generated. The cluster containing the centroid to 8. We keep doing this until the algorithm converges, at which stage the centroid don't move anymore. It has a lot of applications in the field like object tracking and real-time data analysis. So that's it in this video on estimating the number of cluster with mean shift algorithm. Thank you for watching this video.